All right, so this video is designed to help you with your assignment that talks about area and algebra. So the first thing we'll talk about is what perimeter is and what area is. Perimeter is the measurement around a figure. So when we're looking at perimeter, we must be careful that we find all side lengths. Area is the area inside of a figure. So this would be considered the area. So if we were talking about the perimeter, we would be talking about side, side, side. So for our example, we're going to look at that rectangle to the left, which has two measurements already in place. So the first thing we'll talk about is the 3.5 and the 10. So it's a rectangle. So the thing about rectangles is that rectangles have two sets of parallel lines, and they are congruent, which means that they are the same size. So across from the 10, that is the other parallel line. So there is a 10 there. And then there's a 3.5, and then on the other side, there's another 3.5. Oops, gotta get my decimal in there. All right, so with perimeter, all we have to do is identify each side and then add them. So we're gonna take our 3.5 plus 3.5 plus 10 plus 10, and we add them all together. They're all like terms, so we can just simply add 3.5 plus 3.5, and we get 7. And then we have 10 plus 10, which is 20. We get a total of 27. Now, if you look at the instructions above, those instructions told us that we will be using inches as our measurement. So let's make sure we acknowledge that, and I'll highlight it here. We're using inches. So 27 inches is going to be our perimeter for this figure. All right, sorry I didn't change the color there. Okay, so if we scroll down, our next thing we have is what we call composite figures. You studied more composite figures back in the 6th grade. We're gonna briefly go over it here. Oh my goodness, we almost forgot to do area. Hold on, let me scoot back up. So on the rectangle that we had above, area is the inside of the rectangle. Area can be found by several different ways. You may know it by base times height or length times width. In 7th grade, we like to get familiar with the base times height. So area will be A equals length times width, or A equals base times height. Now, let's identify these parts. So when you're calculating area, you only need 2 pieces, versus when you're calculating perimeter, you need all side lengths. Here, we only need 2 pieces. So we're gonna take our numbers here. We got 10 and we have 3.5. We'll call 10 our base, and we'll call our height 3.5. So we're gonna take 10 multiplied times 3.5. And here we end up with 35. And there is our area. However, we're using our inches as our measurement. So anytime we are using our inches with area, that was actually 10 inches times 3.5 inches. And inches times inches is inches squared. So when we're doing area, just remember to use inches squared. So our area here was 35 inches squared. Okay, so let me erase that little piece there. Now we can move on to the next one. So our next one was a composite figure. Composite figures typically are just different shapes put together to keep it simple. And I am gonna scroll up. All right. On our composite figure in front of us here, we have what appears to be maybe two rectangles. There's several different ways you can look at this. You can look at this as being a rectangle, one big rectangle that has a chunk missing. So when I say that, what I really mean is like that. So we could pretend like that's one big rectangle, and we could take the area of the big rectangle and then subtract out that little piece. Or what we could do is we could break it down, which I'll erase right now so I can break it down. We can break it down into two rectangles. Some people like to break it down into pieces like this. I think that breaking it down to three pieces is quite a bit of work. So let's be careful when we're doing that. You do get to work with smaller numbers, but then you end up doing a lot of calculations, which could lead to some errors. So less is best. Now let's go, and I would like to show you the example of breaking it apart like this. So we are now going to use our knowledge of rectangles to calculate the perimeter and area. All right, so now that we have two different rectangles, I am going to write with this color right here for the top rectangle. So knowing what we know about rectangles, they have two sets of parallel lines. So at the top here, we have 24. And then we know if this is a rectangle that this side is also 24. And what we have over on the side is we have an 18. So we know if this side is 18, then the other side is also 18. Now, what may be confusing is, but wait, that side over there says 27. How could that be 18? Well, it's easy because the other side over there, it says 27 as a total. Well, that just means that this part plus whatever's down here is going to equal 27. So here's where I'm going to change my color, and I'm going to write with a different one. I'm going to choose green. So we know that entire side over there equals 27. But what we really need to know is how many is this little piece right here? 18 plus 9 is 27. So when you're using your calculator for this, I would take 27 and I would subtract out the 18, and that will leave you with what's left, what's that side length is going to be, which is 9. So the next thing we're going to do, we know that that side is 9. So guess what? If that side is 9, so is this one, because it's a rectangle. They have two sides that are of the same size. The only thing missing now is this little piece right here. We have no idea what it is. So what we do know is that this side right here is 30, and that this piece of it is 24. So to find the rest of that piece, we're going to take that 24 and subtract it from 30, and that gives us 6. So this piece ends up being 6. So now we have 24 plus 6, and we have 30. And 24 plus 6 is 30, and 30 equals 30. So we are good to go. So now we're going to go and do the perimeter. So doing the perimeter, we just kind of need to clean up our work a little bit, because if we don't clean up our work, we'll write down the wrong numbers and we'll calculate the wrong numbers. So I'm going to take a red pen and I'm going to circle the ones that are necessary for our calculation. So our shape originally had 6 sides. So I'm just going to erase them. All right, so we had 6 sides. this whole side right here is 27. So I'm just going to write 27. Then we have another side that is 24. Then we have another side, which is 18. Then we have another side that is 6. Then we have another side going down, which is 9. And then we have 30, which is a total of 6 sides. Let's just go back and count just to make sure. We have 1, 2, 3, 4, 5, 6. And we will simply add those together, and then we will get our answer, which I'll do right here. 27 plus 24 plus 18 plus 6 plus 9 plus 30. So that turns out to be 114. And remember, we're using inches, so we're going to put inches. 114 inches. And it's not inches squared because we didn't multiply anything. We just simply added those numbers together. So 114 inches. Now the next part is going to be the area. So now we have to find the area of this composite shape. This figure, we're going to split it up again. And let's split it back up right there. Now we're going to use those numbers that we had earlier. So let's start with the rectangle on the bottom. I'm going to write with black for this one. We have 30 times 9. 30 times 9 gives us 270. And then we have 18 times 24. And the reason I'm saying 18 is because remember when we broke apart the shape, that part was 18. So base times height, 18 times 24. And let me put that in my handy dandy calculator, my mouse tools. 18 times 24 gives us 432. And we just add those together because that's the area of the whole thing. We're not just doing the area of one, we're doing the area of the whole thing. So the area of the whole thing is 432 plus 270. And we end up with an answer of 702. Now we're doing area, so don't forget, anytime we're doing area, our inches are squared. So we are working with inches squared. Alrighty, so those are the first two. Let's move on down to the last section. And now we're talking about the perimeter of algebraic figures. Now this you may remember from 7th grade because this is the material that we have been covering. The first part here, we have to identify how many sides we have. We're working with 5 sides. We have a pentagon. It's not a regular pentagon. A regular pentagon is one that has all sides that are the same size. This is an irregular pentagon, which means that the sides are different lengths. So the sides are different lengths. Let's go ahead and write this out. So perimeter, we stated, was us calculating the length of each side and adding it all together. So we're going to take our x minus, let me write that a little clearer. Alrighty. So we're going to take our x minus 4, and then we're going to add, I'm going to go in clockwise direction. Clockwise goes in the same direction that the clock ticks in, which is going to the right. X plus 3 plus x minus 2 plus x plus 1. And we are all done. We should have all 5 sides. So let's just go make sure we have x minus 4, x plus 3, x minus 2 plus x plus 1. Now, the next thing is we're going to rewrite this using the commutative property. But I noticed that all of my x's are positive, so I may not want to rewrite them. I might just want to count all of my x's. Just remember that the sign in front of the term is what carries it. So if there's no sign, then it's positive. So we got a positive x plus another x plus another x plus another x plus another x. We have all positive x's. And remember, if there's no number in front of the x, there is a 1. There is one x. We just don't write the x or the negative x. So if there's a negative in front of it, that's a negative 1. If there's nothing in front of it, it's a positive 1. So we have 5 x's. Then, oh, wow, we have some negative and some positive numbers. If we are still trying to fully learn those, let's do this little interesting technique. We're going to draw a t-chart. We'll label one side N, one side P, and then we're going to have where we just write down how many we have of each, and we're going to take the absolute value, which means we're just writing the number, the distance it is from 0. So for negatives, we have negative 4. Oops. Hold on. Trying to get it where I can write it for you. We have negative 4 here, because remember that term takes that sign. We have positive 3. We have negative 2. And then we have our fancy little positive 1 over here. All right, so our N and P chart, we had negative 4. Oops. We had negative 2. We had positive 3 and positive 1. Which one do we have more of? We have more negatives. And let's see how many. We got 6 negatives and we got 4 positives. We have 2 more negatives than positives. So our answer is going to be negative 2. So we end up with 5x minus 2. Now, you wouldn't be wrong if you said that you have 5x plus a negative 2, but more than likely, if you're looking for that to be a multiple choice answer, I would go with 5x minus 2 unless there was like a multiple response where you had to select all that could apply. So 5x plus negative 2 would be in there, but get used to seeing it the way it is, 5x minus 2. And that is our perimeter. Oh no, I erased it. And that is our perimeter for our answer here. Next, we're going to calculate what is the perimeter of the figure if x equals 3. So this is a cool question right here where we're getting to substitute and take it step by step. So substituting means that we're just simply going back in and we're going to say what x equals. All right, so 5x minus 2, if we substitute that x, then we end up with 5 times 3 minus 2. Anytime the variable and the coefficient are side by side, you're multiplying them. So that's why we multiplied 5 times 3. And we ended up with 15 minus 2, which equals 13. Let's say your comfort level was not there yet, though. What you can do is you could go back up to the very top of the figure, and you could take these x's and substitute those for 3's, and you would end up with the same result. You could do 3 plus 1 plus 3 minus 4 plus 3 plus 3 plus 3 minus 2 plus 3. That's a lot more calculations, so you're more likely to make a lot more errors. So just be careful when you think about venturing into something like that. All right, the last one here, we have the perimeter of this trapezoid. So what we're going to do is we're going to calculate each side. I'm going to just draw the missing A right here. And we're just going to add it up. We're trying to find the perimeter. We're just adding. So we're going to take, let me find some space to write this. Scoot it out one over. All right, so I'm going to switch that color up, maybe a light blue. Okay, so our sides are A plus 12. And then we have, plus A plus A plus A plus 8. Now, we're going to look at our A's. They are all positive, so we're in good space here. We have all these positive A's. Let's just count them up. We have 1, 2, 3, 4 A's. And then we're going to take our constants, which are 12 and 18. They're both positive. I think that's easy enough for us to do. And we're going to take those and add those too. So 4A plus 20. 4A plus 20 ends up being our perimeter. But the question makes us go a little bit further. It says, what is the perimeter of the figure if A equals 1/2 of an inch? All right, so now we're going to take that 4A plus 20 and we're going to substitute the half. Now, again, you could go back up to your figure and you could just say a half plus 12, a half plus a half plus a half plus 8 and do it that way. But I think it's simpler if you just go and substitute the A. And we know that A equals 1/2. So 4 times 1/2, anytime that we're multiplying a whole number, we put a 1 underneath it. And remember, when we multiply fractions, we multiply straight across, or you can factor out the insides and you'll get your simplified answer. So 4 times a half equals 2. Don't forget, we still need to add our 20. And let me get my pen going. Plus 20 equals 22. So our answer ends up being 22. 22 inches, sorry. 22 inches. All right, so last thing is your actual assignment that you get to do on your own. So I'll just briefly talk about it. Again, this is a composite figure, so you could either create your shape. You can create a whole shape and then subtract out that corner piece, or you can just calculate the sides of each one. Just because we're incorporating variables doesn't mean that this is any different from what we've been doing. Actually, you know what? I'll just jump in and start you guys out on a good path. Okay, so you have this rectangle and we're missing a chunk here. Now, what you could do is you could calculate the entire perimeter as if that side was 6. And then you could subtract out whatever this one is. But that's a lot of work. So let's take the route of finding out the length of each side. So we know for sure that one of these sides, the whole thing is 6. And this side is, this piece of it is 4. To make the other piece equal to the other side, and when I say the other piece, I'm talking about this piece here, all we would do is add. We would add a number to that. So I'm gonna let you figure out what number you need to add. And the same thing goes for your 3a plus 4. Your 3a plus 4, you already know what part of it is. So really, in order to find out the other part, you just need to subtract that 2a from that 3a plus 4. And once you do that, you'll be able to walk through the steps of finding the perimeter. If a equals 3/4 of an inch, and then you're going to find an expression for the area of the rectangle, which means you're going to most likely break your rectangle into 2 pieces. However you want to do that. Some of you may want to do the whole rectangle, but I encourage you to break it into 2 pieces. And then you will substitute your A, and then you will find out what your area is of your rectangle. Let me know if you have any questions. I hope this helped you. Have a good day.